Hey there. We are going to cover a variety of different topics in this video, including namespaces, templates, and the standard template library. In our first exercise, we are going to start with namespaces. So here we'll have a namespace called geography. In geography, we'll have another namespace called topography. And then we'll start to access this with a namespace alias. We'll also try the using directive so that we can bring in a function and call it. So let's start with our file here. Let's see here, new file, and we'll call this one geography.cpp, and here's where we'll put our geography namespace. So we write namespace, and you can see it's a special keyword, so it changes color. We'll call it geography. Inside the geography namespace, we'll have a namespace topography. And now, in my main file, so I suppose I should make a main file, main.cpp. This will include geography. What do I have to do? Create a namespace alias topo for topography and use this to access the floats map length and width length. So first let's put these floats in here. So float map length equals 12.5, sure. And map width equals 13.5. Okay, so now I want to try to access these two things. One way to do it is I can do something like, and let's also make sure I can print things. We can say cout geography, topography, map length. And let's just see if this actually goes. Make run. There it is, there's my 12.5. But look how much I had to write just to grab that map length. It's quite a bit. I need to go into geography and topography, and then finally get the map length. So to shorten this, one thing that we can do is we can say that topo represents geography : topography. And this is setting up an alias called topo, which we can then use to save us from having to write this whole thing out every time. So instead of writing this out, I can shorten it down to topo. And you can see it'll just do the same thing. Oh, what did I mess up? Geography does not name a type. I sure hope it does. Topography dot clear there. Topo is not doing it. So clearly this didn't work. And then what did I mess up in my declaration? So let's see here. Did I put using namespace topo? I feel like that might be what I messed up. Nope, that's not it. This is just namespace topo. There we go. Okay. Mixing this up. I'm getting ahead of myself because using is supposed to be the next thing that we're doing. So topography is the topography, topo is the topography namespace from geography, so we can shorten things like such. And now we, I think, want to use the using directive after that. Okay. So the using directive, we've seen this before, using namespace std to grab the standard template library. The standard library, I should say. This allows us to essentially operate the entire time as though we are in that namespace. Now, I want to have a function map area, float map area, and this is just going to return map length times map width. And now I want to call this function. Well, one thing I can do is I can obviously write out topo : the thing, or I can just say using topo. Output the map, what do I call it? Map area. Let's local map area, yeah. And so there's a variety of different ways I can write all the things out that are here, but this is the shortest way, but it now comes with a cost, is that we're assumed to be operating inside this namespace the entire rest of our program. Maybe that's okay, maybe it's not. It's something to consider. But now I can make run. What's up? Expected nested name specifier before top. Now it might be the case. Oh, sorry. Using name. I keep forgetting the right namespace. Using namespace topo. There we go. Boom. And there's my area right there. So namespaces, a way that we can, for instance, put in some names in here that may appear elsewhere. Maybe it's the case that the map length of some other map is a different variable with the name map length. To make sure I don't mix them up, I probably want to do topo : map length. But if I don't care, I can just say using namespace topo, and this will always access things from inside the namespace, whether or not I want to be there. So that's our first exercise. Let's move on to the next one. Okay, in our next exercise, we're going to make a template class called coordinate inside the geography namespace. This class is going to have two class constructors. One is going to take a float, which will be the degrees, and the other will take 3 integers, which are degrees, minutes, and seconds. And then for the float option, minutes and seconds will just be 0. So to begin, let's take our code, put it into another folder, and here let's go to geography, and we'll copy this in here. Okay, so our class is called coordinate, but it is going to be a template class. And what this means is that before I even go into my class, I need to say this is a template class, and there's going to be a type t, which I have not determined, but it could be a float, and it could be an integer. It's not necessarily specific. The variables in my coordinate class are going to be degrees, minutes, and seconds. But what is the type of these? Well, it'll depend on, is it the float version or is it the int version? So since this could be either or, we're going to use t as our substitute for what the type is. So it could be degrees, minutes, seconds that are all floats or all ints. When I build a coordinate, I have one option, which is to take in a float. So I can say float d for the degrees, and I can assign that to degrees. Also for the minutes, I'll assign 0 float, and for the seconds, I'll assign 0 float. Now, the other coordinate constructor I'll get is for a trio of integers for degrees, minutes, seconds. And here I'm just going to assign them respectively, degrees, minutes, seconds. And to make sure this actually works, we're going to have void display. Void display is going to just print this stuff out. I suppose I need to steal... oh, do I not have IOStream? Huh, weird. I thought I did. Very strange. Okay, include IOStream. Did I have IOStream in the one over here? No, I feel like it's supposed to. Very strange. Okay, well, we'll put IOStream in there because it should be there. And then this is where we are right now. We'll put IOStream in our geography CPP, and here we will output coordinate data. And we'll go with degrees. And here we'll put the degrees, and then we'll do minutes and seconds, minutes and seconds. Okay, so we got our coordinate template class is part of the geography namespace, and we could have float versions, we could have int versions, and let's try to actually make some of these things. So let's define another alias. And we'll say that, so how do we make a coordinate? So you need to go in the geography namespace, class is called coordinate, and just like when we do with a vector, we need to specify what type it is. We'll need to say what kind of coordinate we're talking about. Let's say we want to do a float. What I can do is also rename this to be something else. So let's call this an f-coord, float coordinate. And I can do the same thing with an integer as an i-coord. An f-coord pointer fi, how about f1, will be a new f-coordinate, and we'll pass it, 26.f. And then we'll make a integer coordinate, I1, which will be a new integer coordinate with 3 numbers, 1, 2, 3. And now I can say f1 display, I1 display, and we should see our displayed coordinates. I'll comment out everything else that doesn't need to be here, and let's see if all this stuff works. C dot dot. Oh, am I in the wrong folder again? This is in number 2. This is, yeah, number 2. Okay, so this is just in the wrong spot. I should be over here. Make run. A template ID may not clear in a using declaration. Oh, I think I have given this the wrong name. Let me check here. Oh yeah, I keep writing the wrong names for things using in namespace, and the one I'm actually looking for is called typedef. There we go, typedef. And so the mistake I made here is just the wrong keyword. But what I want to do is define. Oh, and I don't think I need the equals either. I think it's just literally define this thing as f-coord, this thing as i-coord. I think that should fix this. Clear, make run. There we go, and look at that. I got my coordinate data from my floating point version, which doesn't seem to have done what I wanted, though. Let's take a look. So it gave me 26. Did I give it 26? Oh yeah, I did 26 point. Let's give it actual, decimal point there. There we go, 26.8, no minutes, no seconds, and the coordinate data for the integer is 1, 2, 3 in order. And you can see that both of these are using the same class. It's called coordinate, but I have 2 different versions now. One of which allows me to have degrees and minutes and seconds all as floating point numbers, and another where they're integers. I can obviously be more creative about this. I can decide how to switch these things around. But the main thing is to make sure that if you do support other types, that your code will still work with them. So for instance here, I'm printing them out. And the way that we print out floats and ints is basically the same. The computer knows how to distinguish between these things. But suppose that degrees was some other type. Maybe I made up some other kind of number class. If I am not able to output that number class, this code will not work and I'll have some problems. But for something like what I'm looking at here, it looks like I can manage with basically any kind of number and it'll work pretty much okay. All right, so that's exercise 2. Let's move on. In our next exercise, we're going to make a specialized version of the template class for string data. And what it's going to do is it is going to parse a string such as 65, 45, 39 into degrees, minutes, and seconds. And we're going to include a library called sStream. This is string stream. And we're going to use a constructor that's given to us. And this constructor is going to be helpful because what it will do is it will actually take this kind of string and compartmentalize it so that it will fill in all of the different variables that we're dealing with. So first of all, let's make clean, clear everything up. Grab the code here, copy it, and throw it into another folder. Example 3. Okay, and here I'm going to make another version of this class. But here we're going to do something different. So if you see in the slides, we're going to declare a class that isn't just with a type name t, it's specifically going to be strings. So we're going to do the exact same thing for our coordinate class. So down here, we're going to have a template, but instead of putting type name t in those brackets up there, we're going to in here say that this is specifically for a string. Now, my display is still going to do the same thing. My degrees, minutes, and seconds will still be, well, in this case, I suppose, be strings as well. because I don't have T anymore, I just have strings. And the slides gave us the constructor that we're going to use, which looks just like this. Boop. There it is. Space it out nicely. And now what we have is another version of the coordinate class that works specifically for strings. And we have it like this because we handle strings a little differently than we handle our coordinate class. Or at least we have the option to if we want to. So for instance, instead of using the arrows here, because degrees, minutes, and seconds are actually strings, I can replace these with plus. Some parentheses around all this stuff. Parenthesis. As just one example of something I could do differently. In my main, let's make a S-coord. So this will be for type string. S-coord S1 is a new string coordinate, and let's do the one directly from the slides. 65, 45, 39. S1 display. Okay, let's go. Let's see what we get. Oh, I got some problems. Has initializer but incomplete type. What's going on there? I'm not quite sure what that error is. Oh, I forgot to include the string stream. That will do it. String stream. And look at that. Degrees, minutes, and seconds all have been filtered into their appropriate places. Just like that. And so now if we want to, we have the ability for a coordinate, if it happens to be of a type that maybe have unusual behavior that we're not used to treat it in a certain way. Maybe it's the case, for instance, that for most coordinates we want to be able to, say, add them together. But for strings, maybe we don't want you to be allowed to do that. In that case, we can define some behavior that is for the general coordinate type and not define it for the string type, or vice versa. Okay, so as our third exercise, let's move on to our last one. In exercise 4, we're going to explore the standard template library a little bit by looking at a couple of parts of it, namely pair as well as map. So we're going to make a location class in geography. It's going to have a pair of coordinates, and it's going to have a name. The map container from standard template library is going to store some of these locations. We'll use the name of the location as the key and a pointer to the location as the value. So this is two parts once again. Let's clear everything up and copy everything over into the fourth folder. Okay, so let's grab the instructions here. My geography.cpp. Okay. So I need a location class inside of geography, and it's going to need to know what coordinates are, so I'm going to declare it after I declare coordinates. So my class is called location. I can also make this a template class. And we'll keep this one real simple. Just going to publicly have, so it is going to have a pair of two coordinates. So the pair class similarly needs to take two things. And it's going to take two kinds of coordinates. So it's going to take, and we'll assume they're both the same. So a coordinate and another coordinate. And this is going to be the coordinates. And the other variable is going to be the string name. So these are my, this is what constitutes location. It's a pair of coordinates plus a name. And that's it. I'm not going to do anything fancy with this one. So now that I have this, let's make sure first of all that I can actually make one. So first of all, I need to have two of the same kind of coordinate. So let's do S2. So I have a second one. We'll just add some numbers to this. Let's clear out my display calls. And let's do location. And this will be a string kind of location. sloc equals location, or actually, I don't have a constructor, do I? Let's give this one a constructor. Location given a, actually, we won't bother with the constructor for now. We're just going to manually assign some stuff, but I do encourage you to try out putting in the location. So here's our location, sloc dot coordinates. So this gives us the pair. And now if I want to actually assign something to the pair, I need to say dot first, and that can be the first one of these, and the second one can be the second one of these, and the name is space, some space. Let's get a display function at the very least, though. So to display, well, I have functions to display coordinates, so what we'll just do is we'll say coordinates dot first dot display, coordinates dot second dot display. We'll also say name has coordinates, and those will be the coordinates. So now I have a display function for my location. So now I can just say sloc.display. Let's see if I have made any mistakes that need to be corrected. These are in the right. I'm always doing this, always putting the wrong files in the wrong places. What we'll do is we'll rename these. So let's just switch this one to 5, this one to 3, this one to 4, just to make sure everything's in the right spot. Clear, make run. Ooh, what I messed up? Yes, I meant geography location, for sure. So let's fix that. Geography location. Clear, go. Ooh, lots of problems. Okay, what is the real issue? Use of deleted function location. I don't recall deleting it, but maybe what we should do is make clean just in case. Interesting. Okay, no, it really wasn't happy about that. Let's just give a constructor. Oh, I think I see the problem. So when I tried to make a template class, note that they don't have any blank constructors. So I have a bit of a problem. So what I'm actually going to do is I'm going to make it so that these are not the coordinates themselves. It's actually just pointers to those coordinates. And that way I can do arrow display. I can do arrow display here. And in my main, I can actually just pass S1 and S2. I think that's a little cleaner. Let's try handling things that way. A pair of pointers, grab those. Let's try this out. Clear, make clean, make run. Hey, there we go. Look at that. So my space now has these two coordinates, and each of these coordinates is a different string coordinate that are put into a pair inside of my location class. So this is how the pair class works. Basically, you just have a first and a second. It's a tuple. And you can declare, you must declare exactly what the type of that tuple is. So in this case, it's just two coordinates, but it could be a bunch of other things. The map that we're about to make is going to also have pairs, but the pairs here are keys and values, and the key is going to be a string, name of the location, and the value is going to be a pointer to that location. So we'll make a map. To make a map, I need to say include map. and we'll make a map. Also have to dictate what is the type of this. So this is going to have strings for names, and it's going to have these locations, pointers to these locations as the second part of it, and we'll call this my map. And so I can say my map of slock.name is equal to the address of this S location. And so now what I've done is inside of this map, I have put in a pointer to the location that I declared earlier. So let's say I make a second one just for fun. How about my second one is both these two coordinates here. Then this is slock2. Don't need to display anything right now. This will be space number 2. We'll do this again for the second location. And now I can, for instance, go, my map location2.name, and we know that this is going to give us a pointer to this location, and that location has a method called display. So let's see if this displays correctly. Oh, when I mess up. Sorry, it's not map, it's standard map. Make clean, make run. And hey, there's my second location. And I believe I can also do a for each. Let's see. So for, I believe it will go through the strings in my map. My string in my map. I should be able to do my map, my string, arrow display. Let's see how that goes. Does not like that? Okay, it was worth a try. I don't think, perhaps you can't do a for each in the map, but that's okay. Let's actually check out map and maybe see if we can get something from there. So what does map have? Map has our keys and our values. The values and keys are whatever type we want them to be. Now, let's see if there's some sample code. There's usually sample code that helps me do some stuff with it. Looks like I can, oh, that's right. So everything in a map isn't, I was almost there actually. It shouldn't be for each string. It's actually for each key value pair. So here, typically, we're going to expect that everything inside the map is going to be a pair where all the keys are unique. So I believe I can actually correct this by, instead of grabbing what I was grabbing here, I can say for each std pair of these things in my map. I suppose I'll call this, I don't know, my pair. Let's do my pair dot second display. So my pair should be the name location pair. I'm going to grab the location part and display it. Let's see if we can get this one going. Hey, look at that. For each location, space and space number 2, inside my map, I can output the data that's in there. And this can be super helpful if you need to use this map data structure. Reasons for using this will become more evident, I think, in the future of your CS career. But maps, dictionaries, hash maps are all things that you will end up using a lot in the future. And implementing them is really a pain. So rather than having to implement all of the way that these things work yourself, it's very convenient to just say, hey, we're going to use our own map. Map is just like Python dictionary in the sense that you have keys and values. So if you're used to using Python dictionaries, you already know how map works. The main tricky thing is to be mindful of the types that are involved. When you declare a map in C++, you have to say exactly what types are in there. Similarly, the elements of the map, if you want to iterate through them with a for loop, are a set of pairs of the things that you said were in the map. And so here, this is a messy looking line, but what it will do is it will go through every single pair of things in the map and let me grab all of the locations that are there. So that's it for this video. Thanks for watching. I encourage you to check out more of the standard template library to become more comfortable with other parts of it, such as some of the methods that are included. But otherwise, I will see you in the next video.